I have a problem. I'm terrible at basketball. But my actual problem is that I'm sick of carrying these keys around with me. I'd like to figure out a way to remove as much bulk as possible from this keychain. And I think the best way to do that is to remove the garage door opener. And the best way to remove the garage door opener is to give myself the ability to open the garage remotely. So I started off by opening up the garage door remote to see if there was a way that I could somehow trigger it. Basically, I want the ability to open my garage door from my phone. And that's what we're going to figure out. Luckily for me, I got broken into twice within 7 days a couple of years ago. When that happened, I decided to get a bunch of CCTV cameras. So I have 4 cameras scattered around the outside of my house, and one of those points directly at my garage door. The reason I mention this is because it means I can monitor the door remotely, which means I don't necessarily need a mechanism to confirm whether or not the door is closed. That might be foreshadowing for this video, but I guess you'll have to stick around and figure it out on your own. Eventually, I figured out you can simply short any of the solder pads for these switches to ground, and that switch will fire, which means if we're able to trigger any of these switches mechanically or automatically somehow, then we would technically have a way to remotely trigger this remote. I figured if we could somehow send an electrical signal to one side of the switch and just connect the other side to ground, then we might be able to use an Arduino to complete that circuit and ultimately remotely trigger the remote. So the next step is to somehow connect these pads, and I'll be honest, I'm pretty terrible at soldering as it is, but soldering something this small is something I've never done before, and it proved incredibly difficult. I'm not going to make you sit through all of it. I'm just going to give you this very short time lapse of me soldering and looking relatively successful. Once I finally left my shed, I had a garage door remote that had 2 leads coming directly from either side of the switch. So the idea was to connect one side of that switch to a digital pin on my Arduino, and then the other side simply goes to ground, and we should be able to send an electrical impulse of some description to the ungrounded side of the switch, which should then short the switch to ground and ultimately trigger that remote. So time to write some Arduino code and figure out if we can actually make it work. But first, and I think probably most importantly, dark mode. Then I'm going to write my first test script here, which is just going to loop every 10 seconds, opening and closing the garage door. Basically, the idea of this script is we initially set the button pin to input, and then in the loop we will set the pin to output, and then low, which will set it to 0 volts and ultimately ground both sides of the switch, which will then open and close the garage door every 10 seconds. And that is a success on our first set of Arduino code. And the fun literally never stops here. Now we're going to add the ability to trigger this via an HTTP request, or technically a request to the USB port of my computer. And this will ultimately enable us to create a way for this to be triggered via HTTP. And that will be the crux of how we control the garage door remote from now on. Now, in this new batch of code, we have basically added 4 different things. We're now asking the Arduino to check if any characters have arrived over USB. We are then asking it to read everything up until the next line, basically. And we want to place that into a string called command. We then trim that string to remove any leading or trailing white space, and then check to see what command is. And if it is exactly open in all caps, then we play the same loop that we did previously. And this will remain the same from now until the end of the project, which for anyone watching this won't be a very long time, but for me was longer than I care to admit. Because how do you know when a project's finished when you're just having so much fun doing it? Now, I won't be spoiling or jumping ahead a little bit here, but I want to give you an idea of what the actual Python code looks like for this part of the project, because it is important to see how we're actually handling these COM port requests via the Arduino. So first of all, we initialize the serial port, which makes sense. I've always got this plugged into my server PC, which has it on COM8. And then if we scroll down just a little bit more, we have here our serial trigger. Basically what it does is creates a subpage within the web app called /API/open. When a user attempts to load that page, it will write open to the serial port. It will then flush the serial port, and it'll also create a log for the website. And there's some error checking stuff here as well. And ultimately, that's all that's required. Roughly 15 lines of code within the web app is part of the actual opening and closing of the garage door. And again, definitely a bit of a spoiler seeing this web app, because when I first created it, it was just this single page camera view. This open button was big and right here rather than in the banner. And all I had was the open button and this live feed. When you click the open button, that then opens the garage door, the exact same as the remote. You can click the open button while it's still moving and that will stop it, or when it's all the way open, you can click the open button again and that will ultimately close the door. So that's the basic premise of this project. That's how we'll interact with the garage door moving forward, except now having a garage door opener plugged into a USB socket on my server PC didn't sit super well with me, just because what happens if it randomly opened the garage door for no reason? So that being the case, I figured try to figure out a way to get myself notified if the garage door has been left open for whatever reason, and that's where things started to get complex. But before I jumped too far ahead of myself, I decided that I would 3D print a case for this contraption for the Arduino as well as the garage door opener itself. As you can probably tell, I am by no means a wizard in Fusion 360. But I know the basic commands and I know what I wanted to build, or I at least had an idea of what I wanted to build. So I just recreated the Arduino itself and then recreated the garage door opener and came up with this case. And once I had modeled it, I popped it on the printer and immediately found it was a little bit small. So I had to scale it up and reprint it. However, at this point, I think my power went out or something and I had not saved the Fusion 360 file at all. So all I had was the STL and nothing in Fusion. So I just scaled up the STL, reprinted it, and it still doesn't fit super well, but it is what it is. It's just gonna sit here on my server PC anyway. I just wanted to keep it nice and compact and make sure it didn't break anything. And now this is gonna be its final resting place, sitting on top of this computer right underneath my 3D printer. So yep, rubber bands and everything, it will do just fine. Now for the super fun part, building a Tensorflow model so that I can have an AI predict whether or not the door is open. So the first thing I need to do, as you can see here, is label a bunch of images of my garage door. This took a long time. I remember going through this on like a Saturday afternoon for like 2 hours, and at one point I had eventually labeled around 8,000 different images, and I really wondered what I was doing with my life. Like realistically, I'm sitting here on a Saturday afternoon categorizing pictures of my garage door. Anyway, the way I decided to build this labeler was kind of a Tinder-esque app. Basically, it shows you a picture, you press closed, open, or unsure, and I also gave myself the ability to label these using my keyboard, and it also has the functionality to allow swiping of images so that I could jump on my phone on the couch and swipe left or right depending on if it was closed or open. There's also a rewind button in case I accidentally labeled the image incorrectly. Then the unsure button is basically a bin for images I'm not 100% sure on, and if we're being for real, all this app really does is moves images into folders depending on what the classification of that image is. In any case, as you can probably see here, we have quite a few more closed categorized images than open, and it's a noteworthy discrepancy, especially considering for the closed categorization of these images, there's only a single position that the door can be in. So there's only so many pixels that can change, there's only so much lighting that can change, whereas when the door is open, it's functionally infinite how many different images there can be of an open garage door, especially considering we're not only treating the garage door as open when it is completely open, we consider it open when it's an inch off the ground or if it's entirely open. So functionally, we require more open images in the model than we do closed, just because of the possible variance. So now that we have our initial dataset, it's time to train our TensorFlow model. And this will be our AI. This will be our predictor. And I'm not going to pretend that I know anything about TensorFlow. I don't. I got ChatGPT to write basically all of this code for me. But I've learned quite a bit, and I think I barely understand enough about what this code does now. So let me try and explain it to you. So first of all, we're going to build our dataset. All this does is automatically labels our existing dataset that we've already kind of labeled by giving it the inferred label, so open or closed, because those are the folders that they are in. And we obviously have binary, it's either a 1 or a 0, and we have a validation split, which is 0.2 or 20% of the dataset will be used for validation and not for training. And then obviously our image size and batch size and stuff, which is all up here in the constants. Continuing on to build our dataset here. The dsval section is for the evaluation, so that's what the 20% split is used for. Next, we do some pre-processing. So basically what we are doing in these two sections is we're converting the images from 8-bit integers, wherein each red, green, and blue channel is given a value from 0 to 255. Here, instead, we're converting those values into between -1 and 1. That is because the MobileNet v2 model expects and has been trained on images with those values as their inputs. So that is the input that is required. Within build model, we basically decide what we're going to be building the model with, which, as I mentioned, is MobileNet v2 with the weight set as ImageNet, which is a pre-trained filter that we're going to be using. The rest here, I don't understand. Then we get to the section in which we begin training. So initially, early stopping, this will watch for validation loss. And if the model hasn't improved within 4 epochs or 4 runs through the whole dataset, then it will go back and restore the best weights available from the previous epochs. Model checkpoint will save a model each time it improves within one of those 15 epochs, and that's the model that early stopping will use if it does end up stopping. And now we have our 2 phases of training. So phase 1 is the initial training. This will train the model 15 times or run through the dataset 15 times to train the model. Phase 2 of model training will go back and remove masks that were previously added, and it will fine-tune the last 20 layers. And ultimately, we'll save our model, and then we get to move on to probably the most important part of the project. Let's have a look at predicting whether or not the door is open. So as you can see over here, the main page of the web app is the predictions page, which shows the most recent image that was saved in the images folder. For that image, it will show a prediction between 0 and 1, with 0 being a closed door and 1 being an open door in a perfect world. Now, technically, we should call this anything above a 0.5 is open and anything below a 0.5 is closed. However, my model seems to lean very heavily towards the 1 rather than the 0. For this particular prediction, it is 0.8, and for the most part, all of my predictions are over 0.8, and in fact, quite often it's over 0.9. So my actual door model prediction number is 0.98, and funnily enough, it's very, very accurate, and I'll show you the folder for that shortly. But first, let's have a look at what this code actually does. This loop will check to see if a new image has come through. If any image has come through, it will then run the model or run that image against the model and handle the prediction, which does a whole bunch of stuff, which we can see up here. So handle prediction will use the prediction that the model gives to say whether it's open or closed. It will then update the web UI, so it will save the most recent image as a standalone image so that we don't fuck with that image anymore. It will then crop and move the previous image. So rather than cropping and moving the current image, just to be safe, to make sure that we always have a single image available in the images folder, it will crop and move the previous one anytime a new one comes in. And it will also append either closed or open to the end of the file name, as well as the actual prediction number that was given. And you can see that here. It will also move that image to its respective folder. As you can see here, it moved to the closed folder and then added closed and the prediction here. Then, if specifically the state was open, it will note the time at which that image came through. And later on down here, if the state has been open for 5 minutes, it will then send a Discord notification here, which we can see here. It'll tag everyone saying the door's been open for 5 minutes, and then a link to the web app. And it will also include the most recent image. We'll continue doing that every 5 minutes until action is taken or until it moves back into the closed state, which is basically the same thing. And then obviously if it moves to the closed state, it will then set open since to none and last notify to none. So basically it resets the timer. Now we can see here there are quite a lot of images that come through, and one thing you may notice is this backfilling images. So when the app is actually predicting an image, when a new image comes through, there's 2 seconds between each new image. So when the camera is triggered, it will save a new JPEG every 2 seconds for however long the trigger lasts. In that time, the model can only run the prediction on so many images, especially because there's some timers in here that ensure that the image saves completely prior to running, so that we don't end up with a whole bunch of images in the images folder and everything gets seen by the Tensorflow model. We backfill images. So if this script hasn't seen any images for 30 seconds, it will then begin running the model on all other images within the images folder to ensure that each image gets predicted and placed into the classified folder, like open or closed. And we can have a look at that now. So here you can see it always keeps one image, which is this image here. This is mostly because I was running into a bunch of errors when launching the code, because if there was no images in here, it would throw a tantrum. So we keep one image all the time, and the labeler also won't let us label this image. And now we have our classified folder. And in this classified folder, this is where images are placed based on what the prediction is. Some of the earlier images here are probably going to be incorrect because this was when I was trying to make sure that the model worked correctly. So we're in the open folder, and these are all, well, a lot of these are definitely closed. You can see here for a couple of days, my model was having a very rough time. And if we scroll all the way down, you can see here, we've got this model pretty well dialed in, and even images like probably this one, the garage door is just very slightly open, but because the model is predicting anything above 0.98 is open, it recognizes this is an open garage door, which is amazing. That means we have successfully built an AI that can detect whether or not my door is open. Then once it's been open for too long, just in case I leave it open when I go for a walk or when I go to work, it will shoot me a Discord notification and I can then close the door remotely. I've also included a few other things within this web app which are inconsequential for the most part, but for instance, the log of predictions is also included within this page. I obviously still have the live camera tab, which allows us to view the camera from a live view, because as you can see, there is a bit of difference in time between these images, the live and the static image. So obviously the prediction image doesn't update as often as the live does, because it'll only trigger when there's a certain amount of motion, blah, blah, blah. So the live page is still here, and we also have the labeler, which is a little bit less pretty than it was initially, but it is still functional, and you'll notice that the image is pre-cropped now, whereas they weren't before. So we crop specifically for the size of just the garage door so that we're not wasting so many pixels in the model. And I also have a tools page here, which I never actually built out. But the idea was to build a training UI, which would allow me to train the model just from the web app so that I didn't have to run the Python code explicitly each time. A dataset explorer, the idea here was to use the predictions that were placed in the file names to understand exactly where I should set my prediction, but I kind of binked it with 0.98, and that seems to be perfect. As long as I don't change my model up, then it's going to stay there for the time being. I've probably seen maybe 100 false positives out of roughly 20,000 images all up, so I don't really need a dataset explorer. And then finally, the cropper. I built this manually initially so I could crop the images in bulk, but now the prediction will crop those images for me, so the cropper is no longer required. And basically this page will remain here until I get bored or something weird happens. But that's it. We are done with this project for now, and we can rest easy knowing that it'll only be a couple more days until I find something else that doesn't work properly or exactly how I want it to, and begin a new project that takes me another couple of months to finish. Thanks for watching.